ASDIP RETAIN includes the design of different types of retaining walls, either concrete stems or masonry stems. For the image at the left, which is 16 feet high retaining wall, the footing is 20 inches thick, the toe is 4 feet long, and the heel is 5 feet long. For this kind of footing, most probably we will need 2 layers of reinforcement, top and bottom. But what about if the wall is much smaller, like the one shown at the right, which is mostly CMU stems, and the footing is much smaller in this case? Most probably 2 layers of reinforcement in this case would be an overkill. So a single layer of reinforcement is probably all what we need. But how do you specify these two scenarios in ASDIP RETAIN? Is it possible to model a single layer of reinforcement footings for a retaining wall? This is Javier Encinas, and today we're going to present a new feature in ASDIP RETAIN to model single layer of reinforcement footings in retaining walls. Let's get started. The wall at the left is 16 feet high, and this footing is substantial to provide the required safety factors for stability, mostly overturning and sliding. So for this footing, 20 inches thick, most probably we will need 2 layers of reinforcement, top layer of reinforcement for the heel and a bottom layer of reinforcement for the toe. Many engineers prefer to specify a double layer of reinforcement for both, as shown here, for simplicity during construction. Also, it's possible that the rebar that is coming down from the stem hooks into the toe, and then that provides the reinforcement for the toe. In addition, you need to provide a top layer at the heel. Either way, 2 layers of reinforcement are necessary in this kind of retaining walls. But for much smaller retaining walls, like the one shown at the right, which is only 6 feet high, this is mostly done masonry for simplicity as well. But the footing for these kind of walls is also much smaller, probably 9 inches thick or 10 inches thick or so. So 2 layers of reinforcement is probably not necessary and will increase the cost of this kind of retaining walls. I have prepared an example for a wall similar to this one in ASDIP RETAIN. Let's go there and see that example. When you open ASDIP RETAIN, you see the project manager. Here you can see the modules included in the package: cantilever retaining walls, counterfort retaining walls, basement retaining walls, sheet piling retaining walls, and gravity retaining walls. In this case, I have prepared an example for a cantilever retaining wall, which is a masonry wall, very small, 6 feet high. Let's go there. Double click on the example. And this is the template of the cantilever retaining wall design in ASDIP RETAIN. In the Geometry tab, I have specified that the stem material is masonry, opposite to concrete. So 9 rows of masonry, which is 8 inches thick. Graphically, we go to the Graph tab, Construction tab. This is basically what we are modeling here. It's a 6 feet high masonry wall, and then a concrete footing. And the focus on this exercise is to model a single layer of reinforcement for this kind of simple retaining walls. In the footing tab, I have specified a footing thickness 9 inches. The reason of this number is that the minimum hooked development length is 6 inches, and if we add 3 inches of concrete cover, that gives us 9 inches. So this rebar, the minimum hook development length, LDH, is 6 inches, plus 3 inches cover would be 9 inches. So 9 inches would be the minimum thickness of this kind of footings to comply with the development length requirements. We are assuming that the toe length is 1.5 feet and the heel is 1.5 feet as well. We don't have any shear key, so 0. The backfill is a flat backfill, 0 slope, as shown here, 6 feet high. We don't have any influence of the water table in this example. We go to the loads tab. We are specifying the density 120 PCF, specifying the Coulomb active pressure. Internal friction angle is 28 degrees, and the water table is 0. We don't have any other loads, no surcharge, no concentrated loads, no wind, no seismic. With these dimensions and loads, let's check the stability safety factors. Let's go to the at a glance tab. Here we can see a summary of the results. For now, let's focus only on the stability check. With these dimensions, the proposed dimensions shown in this image, the safety factors is 2.84 for overturning, more than 150 passes, and for sliding is 2.02, more than 150 it passes as well. The soil bearing pressure is also very small, 0.9 versus the allowable soil bearing pressure, which is 4. If we check the shear forces, this will give us an idea of the adequacy of the thicknesses. For the stem, the shear ratio is 0.23. For the concrete toe, the ratio is also 0.22, and for the heel is 0.67, which is also okay. Let's go to the reinforcement tab to specify the rebars. For the masonry, let's assume that is number 4 at 16. The reason of using number 4 is that we want to minimize the hook development length. So in this case, if we specify number 4 at 16, we are getting a moment capacity ratio 0.93, which is okay, it's acceptable. It's less than 1.0 for this load combination. If we go to the footing now, there's a checkbox at the top that says use a single layer of rebars, which is exactly what we are doing. This checkbox is marked, so we are using a single layer of rebars as shown here. As opposite as if we uncheck this box, we would have 2 layers of reinforcement. In this case, it's obviously an overkill for this simpler design. So let's go to the one single layer of rebars as shown here. Also, we are specifying number 4 at 12 in both directions for this wall. If we go to the at a glance tab again, for the toe, the moment capacity ratio is 0.20, the development length ratio is 0.80, and the minimum steel area is also passing 0.97 and 0.44. For the heel, the moment capacity ratio 0.47, the development length ratio is 0.80, and then the minimum and maximum steel area ratios 0.97 and 0.67. Everything is passing in this design as shown. If we need to see a more detailed set of calculations, let's go to Condensed tab. Here the calculations are grouped by topic, showing the corresponding controlling load combinations. It's an overturning check, then sliding. Here the stem design. Here is the design of the toe and the design of the heel. If we need even more detailed set of calculations, let's go to the Detail tab. Some more detailed set of calculations with step-by-step calculations that you can follow granularly. It shows also references to the design code. Here is the design of the heel, and here the design of the toe. Finally, in the Graph tab, Overturning tab, it shows the overturning analysis for this wall. Here in sliding, all the sliding pressures that are affecting the sliding analysis, the sliding forces, and the safety factor is 2.02. Bearing, the bearing pressures under the wall. This is the analysis of the stem for the factor load combinations, showing the moment diagram and the shear diagram. And finally, the construction tab, showing the final design. As you can see, it's very easy to design small retaining walls with a single layer of reinforcement at the footing using ASDIP RETAIN. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.